Okay, so if I find the right page here, let's go to the next page. We are going to do number 28 here. So we're doing the disk method here. And we have the region enclosed by the graph x equals y to the 3/2, x equals 0, y equals 2, and we're revolving it around the y-axis. So going to my many screens, here is the graph, and you can see here that this area, my kind of triangular with this little curve here, that's what I'm going to revolve around the y-axis. And you can see here, since I'm revolving it around the y, I care about the y values for my limits of immigration. I'm going from 0 to 2 up here. And my disk method formula for y, remember, just adds really in. I'm going to square what I get, and I throw a pi in there. Not too complicated here. So starting with this, I don't need to figure out my area because this I'm just going to use my disk method formula. So my formula, remember, is a to b pi ry squared dy. And this could be an x if we were revolving around the x-axis, so on the y, so I went with y's. So I want to go from 0 to 2, because I'm matching my picture here, 0 to 2 up here. And then I got my pi. And then I've got my equation, which in this case was y to the 3/2, and I'm going to square that dy. Okay? Then what I'm going to do here is I am going to kind of simplify. I'm going to pull the pi out front so I don't have to worry about it. Power rule says I multiply this, so this is y to the 3rd dy. Oh, that was nice. So this is pi over 4, y to the 4th, 2 to 0. The 0 is going to be 0. So 2 to the 4th is 16. 16 pi over 4 minus 0 is 4 pi. And so that's my area. If I took this and revolved it madly around the x-axis. Now to kind of show you, I gave you this applet, and this works really well for this disk method one. Messing with this one, and it wasn't working as I wanted. So I want to do, let's see here, my curve was x equals y to the 3/2 and x equals 0. Y-axis 0 to 2. Calculate volume. Well, see, I didn't actually try this before, so if it doesn't work and it yells at me, we won't bother with this, but I'm hoping I can get this to work. Oh yeah, well, it agrees with my answer. That's a good start. I want to see if it'll come up with the picture. Yep, so here we can see the nice picture. Here's our solid to give us an idea of what's happening is revolving. There's the x-axis, the y-axis we're revolving around, and we make this cool looking, you know, kind of, I don't know, it looks like a lampshade to me, or maybe an umbrella. I'm thinking summer. It's the, you know, the umbrella you open up over your table. So, but disk method. We know the formula. Make sure you draw, find the right screen here, draw the picture, because that's how you're going to find your limits of integration. It's really hard to find the limits of integration unless you draw the picture. And something like Desmos, which gives you a nice big view, I mean, you can certainly do this on your graphing calculator, but this is where I really like Desmos because it's really easy to see it. I can zoom in, I can get all the pieces, and I like that when I'm doing something like this.